Hey bioteam. So when chemists or biologists try to draw out really big and complicated macromolecules, they'll often take shortcuts by building something called a skeletal structure. And so there's a couple of rules for interpreting this sort of skeletal structure. The first of which is that any unlabeled corner of the skeletal structure is assumed to be a carbon atom. So this is particularly useful for organic molecules that all have carbon in them. So here we've got one corner that's unlabeled, here we've got a second corner, and a third corner that are unlabeled. And so we know that this skeletal structure then would represent a molecule in which all three of those corners are carbon. Now the second rule for interpreting a skeletal structure is that where any of these carbon atoms doesn't have all four of its valence bonds showing, we can assume that it's bonding with a hydrogen. So starting with this first carbon, we can see that this carbon has two bonds. That is, two of its valence orbitals are taken up by bonds, but the remaining two we can assume are bonded to hydrogen. This carbon in the middle, meanwhile, actually has all four of its valence electrons shared in bonds right now. We can see 1, 2, 3. There's a double bond with oxygen. And 4. So this carbon isn't bonded to any hydrogens. And last, we've got a carbon that has only one of its valence electrons in a bond, so we can assume that the other three valence electrons have formed bonds with hydrogen. So we'll go through another example of that here. Let's say we have a skeletal structure shown like so. And then according to the second guideline, we know that carbon has 4 valence electrons available for bonding. And so any bonds that are not visible, we can assume are taken up by hydrogen. So this carbon, for instance, has one of its valence electrons accounted for, but the other 3 then must be bonded to hydrogen. This carbon right here has 1, 2, 3 of its valence electrons accounted for, so the remaining valence electron must be bonded to hydrogen. The same thing goes for this carbon here. It has 1, 2, 3 valence electrons accounted for. So the fourth valence electron we can assume is bonded to hydrogen. And then this last carbon here has only one of its valence electrons bonded. And so we can assume that its remaining 3 valence electrons are bonded to hydrogen. And that's it. At this point, you guys have some practice problems. Best of luck.